All right, cool. Let's do this. So if you download the PowerPoint, this will tell you which dot point it is. And it's graphs of sum, difference, product, and composite. You must know that. That's 1D, 1E in this dot point. Okay, the skill is find the rule of a composite function. But before you get to this, you need to understand what a composite function is. That's what my aim is to do for today's session. Okay, so 1D and 1E. Now let's have a look at 1E. I said a composite function is a function within a function. Okay, what do I mean by that is, for example, 1 on square root of x. Yes, you are expected to be able to draw that graph even though you haven't learnt it yet. You've learnt its individual parts though. You've learnt, please work. No, it didn't work. Okay, I'm going to draw it over here. No, it didn't work. Let's do, why won't you work? I'm going to do it separately on this page. Okay, you've learnt, oh, it does work. No, it doesn't work. Oh, this sucks. Alright, you know what I'm just going to do? This stuff now. Alright, what you've learnt is, if you separate this function out, you've got 1 on x, that's a function, and then you've got a separate function, square root of x. We call it composite function because you can split this up and you say, let's call this 1 on x as f of x. You can call square root function as a g of x. So what I'm really saying is I can say in order to get h of x was the result of substituting g of x, which is the square root of x, into f of x. So think about it. This is 1 on x. I substitute 1 on root x in, and I get 1 on square root of x. Notation-wise, what you're really saying is you're saying it's f of x, but where you're putting x, instead of putting the letter x, you're now replacing that with root of x. So notation-wise, what is root of x? Root of x is g of x. So in your textbook, this is what they write. They say f of g of x. We use square brackets here. The way we read it is this is just saying substitute g of x into f of x. So it's like this. You know how you normally have f of 1? Then you'd say, oh, well, it's 1 on, and you substitute 1 in. There's no difference if I said f of g of x, then all you're doing is you're substituting g of x in. It's just that g of x is root of x. That's why it replaces it to be 1 square root of x. Okay, so that's the first thing you need to understand. A composite function is when you have a function within a function. So I got a square root function within a hyperbola function. Okay, so that's what it means when we're talking about a composite function, right? Now, obviously, with a composite function, it means there has to come with some sort of restriction, things you can do, things you can't do, right? Let's have a look at the things that you can do and things you can't do in each of the individual functions. Let's have a look at f of x. I'm going to take away g of x for now. Let's look at f of x. The graph for f of x looks like this. It's called a rectangular hyperbola. It has asymptotes at x equals 0 and y equals 0. So if I ask you the domain and range, what's my domain? Yeah, x is an element of curly bracket 0. So it can be all numbers except 0. And the same thing with range. It can be all real numbers except 0 as well. Okay, so that's my restriction for 1 on x. Let's have a look at root of x. This is my g of x here. Root of x looks like this. What is that? Root of x looks like this. If I ask you now domain and range for this function, what would you tell me? What is that? What's my domain? Domain is R positive. Can only be all positive numbers including 0. So element R positive including 0. I would use union for including. Okay, and then you've got your range. I'm going to do domain G, range G, domain F, range F. Okay? This is now y is an element, and again, same thing, positive union 0. Now here's the thing. Oh, did I just... All right. When we're talking about to sketch this graph now, h of x, that's what we want to do. Your aim in exercise 1E is to be able to sketch a composite function, which is made of two functions that you're familiar with. Now, in order to make it work, remember, what was the restriction on the first one? The first one said, I will take any number as long as my domain is all real numbers except 0. I will take all my y values as long as all real numbers except 0. Now here's the thing, when you sub g of x, which is here, sub g of x into f of x, what are you really doing? You're really taking g of x, which is the domain. Notice, this is the pre-image, true? That's your pre-image. And you're substituting that into the function f of x. So if I draw the machine, if you remember the machine I was drawing, think of it this way. Let's draw the machine. This is g of x, yeah, which is square root of x. I take a number, which is your pre-image. Let's say x equals 1. Okay? I put 1 into this machine. It spits out another number. So you put 1 into root of x, root of 1 gives you 1. Spits out a 1. And you take that 1 and you put it into another machine called f of x. Agreed? Yeah? But what you're really putting in, that 1, is really g of 1. Agreed? Yeah? So g of 1. Now g of 1, what you're really doing here is you're putting g of 1 into the second function. That's why this is called the composite. Because whatever this answer comes out, that's what you're going to plot, and that's how you're going to sketch h of x. So the first thing you need to be worried about is, does this work? Can I have g of 1 in here? G of 1 is 1. So let's look at the graph. We're like, oh wait, g of 1 equals 1. Can I have 1? Yeah. See, the domain here says, yeah, you can have 1. I can have any number except 0. As long as it's not 0, I'm happy. So what are you really looking for? The only time that it doesn't work is when g of something, so when you spit out a number that is 0, because apparently this machine can't take a 0. So if I spit out a 0 and I try to sub it in here, that's not going to work. It's going to be undefined because they already told you, they said, I can take any number except 0. So what number are we looking at? We're looking at the range. Remember, this is the range. This is the image. You're spitting out a number. It's an output. An image of your square root function has to fit into the domain of your second function. Listen to me say that again. The image of your first function has to fit in to the domain of the second function. Yeah? So another way of saying that, the y values of the first function has to be a part of the x values of the second function. And that's what you're really running here. When you say f of g of x, see, g of x is your y values. The y values have to fit the domain. This is why your one property that you're going to get assessed at the end of year, and I'm so definite it's going to come up, it's not in this form, it could be in any form, but it could be your multiple choice form. Your formula or the property they want you to show is range of G is a subset, or fits is what I sort of call it, subset of the domain of F. This is the one property that you have to understand about composite functions. What I don't want you to do is memorize that, because this only works for F of G of X. Another way of writing f of g of x is f little o g of x. Okay? Now, why does it only work for this? Because the range inside, what are you substituting in? That's a g of x there. So you're substituting a g of x into f of x. That's why it's the range of g to be fitting the domain of f, because that's what you're doing. You're putting in, that's the pre-image, spits out a range. The range goes into f of x. That's why it's the range of G has to fit the domain of F. So if I changed it around, if I called it, let's say if I changed it around and I said, I want you to find G of F of X, this is now different. You see, now this one is now saying, I want you to find sub F of X, which is 1 on X. I want to sub that into root of X. So that means your H of X graph will look like this. 1 on X, that. Okay, which actually ends up being the same thing. Okay? But the differences between the two is this one will now say the range of F has to be a subset of the domain of G. Now I want you to really think about that, okay? Because that's the one concept I'm really trying to get you to understand. Everything else will start falling in if you understand that one concept I'm trying to teach. I'm just trying to say you've got two machines, you choose a number, and that's your pre-image, it's an X value. You put it into the first machine, it spits out, and we'll rub this off, it spits out a Y value, which we call G of 1. That Y value, you then sub into, where do you sub it in? So this is where your domain is, that's where you sub in your X values normally. This G of 1 is a range of G, but it has to work, has to fit or work for the domain of F. Because if it doesn't work, you don't get a coordinate. Because what if I put it in a negative? You see, remember the square root function was, the restriction is it can't be any negative values. What if I subbed in, what if I said X was negative 1? See, negative 1 into G of X, that doesn't work. So that already doesn't work, so then you can't put it in here. But if it works in here, it might not work in here. So the first thing you need is this. You need the range of what you're putting in to fit the domain of the second function. Is that sort of making sense? Yes? Yes, Josh?
Isn't it like more the domain of H because isn't it the domain of F when we're using F being F of G of X?
Yes. This is good. So what you're
subset, that's right, yeah.
Yes.
Yeah.
And so what you're now leading on to is the next part, which I was going to say is part of my PowerPoint, is that once you understand this, okay, the next thing that you should pick up as well is whatever domain that works for this in both machines. Remember the final thing is this is H of X. In order for H of X to exist, for it to work, meaning that you're actually going to get a coordinate, is that this has to fit this, which is the first condition. But the next thing you'll realize is what Josh is mentioning, isn't the domain of G of X is actually just the same thing as the domain of H of X. Because let's say I said, I'm going to put 1, 2, 3, 4 into the machine, and I figured out that 1, 2, 3, 4 is okay, then doesn't that also mean this is the domain for H of X? Because H of X is what X values can you put in? Well, I can put 1, 2, 3, 4, it goes all the way in, and it comes all the way out. I get H of 1. I get H of 2. I get H of 3. So the second property for your composite function, domain of G, in this case, for this particular question, domain of G is equal to the domain of F of G of X, which is in our case, domain of H of X. Really try to dwell on that, okay? Because that's really all they're trying to teach you. Okay, all the exercises and whatnot, you're going to learn to sketch, find the equation and whatnot, but really the concept that you have to take was that you've got two different machines. What you put in is the Y value of the X value, then it spits out a Y value. That Y value is your range. The range has to fit the domain of your second function. If it fits, you spit out another one, and that's your H of X. Okay? Now, while you're sort of thinking about that, I'm just going to rub all this off so it doesn't confuse you. Which one should I rub? Because once you can figure out domain and range, you can figure out what the graph will roughly look like. Yeah, I'll just take that off. There you go. Yeah. All right, here we go. Let's now go to, finally, what I really try to say here. So if you understand is there's two machines, let's have a look at what I was saying. This could be broken into two functions as, and I wrote here, 1 on X, square root of X. We know that, which means I can see this as f of, and you sub g of x into f of x gives you h of x. I go to here, there's another way of writing it, you can write f of g. That's what it means, f of g. Okay? So f of g. What you're going to do here, read an f of g. What I want you to look at now is here. Let's visualize. This is your hyperbola, f of x. This is your square root, g of x. It makes sense that I'm going to substitute the y values, okay, y values. These are your y values. This needs to be a part of the domain of f of x, okay? So whatever doesn't work, like over here, you can't sub anything over here, okay? But what you need is right here at x equals 0, that doesn't work because if I sub g of 0, so if I put x equals 0 into g of x, this spits out g of 0, which is 0. But in the second machine, f of g of 0, you can't do. Because remember, this hyperbola cannot take 0. And so therefore, f of 0 is undefined, so therefore, this graph doesn't work. Okay, now we're going to try to talk about this in the next lesson, and I'll try to push you forward. Try to look at this again, read it, but I just want you to read. Okay, don't do, read. If you understand it, that'll be great. Okay? Try to think more about that. Hopefully the pen works next time.
Has it happened all here?
No. Oh, recently, yeah. In the past, it's been working fine. I don't know what's going on.